This is our first problem on uh, base plate design. We will solve two maths, and this one is the first one. So the thing you need to know is the proper dimensions of the structure that you have, the cross section right over here and the elevation right over here. You need to interpret all of the dimensions right over here and with a standard one. Like if I go a bit upward, uh, you have to know the name of all the dimensions. We call the this dimension as n. But why? The n is the dimension that is parallel to the moment. So we assume that the moment is occurring this way or this way. So n is parallel to the moment direction, capital N. And your B is perpendicular to the moment direction. B is the you can call that width, and A you can call N as your total length. And this D value you get it from the AISC manual, and this D value depends on the section you are using. In this case, this is the I section, and you'll be told what section you are using. For that section, you'll get the depth, uh, total depth. And the important thing is F. What is F? F is the distance from the bolt, from the middle of your bolt or tensile bolts right over here, and the mid depth. This is F. And what is X? X is the distance from the middle of your flange, to the middle of your bolt. This is X. And what is M? M is the distance from the edge, if I'm not wrong, it's from the edge or middle. Whatever, it should be from the middle, if I'm not wrong. Whatever, it's the distance either from the middle or from the edge to the uh, concrete edge. So this is M. So X, M, F, and D, and N. These are the things that you need to know. So you'll need them in further study. One more thing, that is your flange thickness. You'll get it from the AISC manual for the particular section. So you'll need to find out the M value, that is this, and the X value. You will see that later on. So for the M value, you just plug in the value of N, which is parallel to the direction of moment, and you find the depth from the AISC manual. And for the X calculations, you get the value of F. You will be given these dimensions, and you have the total depth of your column section, and you know the flange section. So using these two equations, you will find out the value of M and X. You will need them later. So this is the first part, that is to be introduced to the dimensions. The second part is you need to find out the eccentricity. So eccentricity is your moment, which is 120 feet cube. So you just multiply it with 12 and divide it by the force. In this case, the force is 130. And you'll get a value of 11 point, is that, how much is it? 11.08 or 11.08 inch. And then you will compare it with n by 6 value. If this value is greater than n by 6 value, then uplifting will occur. So we'll see that. Your n value is, in this case, 22. So you just divide 22 by 6 and you get a value of how much value you'll get. 22 divided by 6 is 3.67. So your eccentricity value is way greater than n by 6 value. So uplifting will occur. So that's the first thing. Later, what do you need? So in design part, you have been given the number of bolts you'll use, which is this, or rods, anchor rods. Sorry, anchor rods. You have been given four anchor rods and the spacing of that, and the strength of that bolt, sorry, anchor rod is also given. So you're using ASTM A307 anchor rods. The design in design, but you will just find out the diameter of that anchor rod. So you need to find out the diameter, one thing, and the other thing is that you have a this plate. We call that plate. We have to find out the thickness of this plate. So these are the two things you will design. First of all, you will find the diameter of your anchor rod. Second of all, you will find the plate thickness. So these are the two things you are asked to find out. So for that, you will design uh, the diameter of your anchor rod for tension and for shear. So the shear is given, that is 30 kip, but you don't know the tension that will occur in the structure. So the tension will, if the moment is this direction, or this is clockwise direction, the tension will occur in this two anchor rods. So we'll find out the tensions, total tensions that will come, then we'll divide it with two, then we'll get the tension that will come in the on these two anchor rods. So how do you find out the tension? So we'll find out the tension. So we'll do all the calculations to find out the tensions because we know the shear already. So we'll just find out the tension. So for tension, you have an equation that is the tension will be equals to Qy minus Pu. Here Q is bearing is the ideal load for bearing. What do you mean by that? See, if uplifting occurs, it these anchor rod will give a tension this way, and you have a eccentric load that is occurring downward, and the soil surface will give an upward force right over here. So you can see that the tension is downward and the external load is downward, and the soil uh, is giving an upward force. If we consider that if it is giving a Q uh, upward load, and it has a bearing length of y, this y, then we just can say that the downward force is equal to the upward force. So we know the pu force, that is external force. We'll find out q and we'll find out y. So from there we can find out the value of tension, that is this. So our calculation will be for to find out the Q and Y. Here Q is the ideal load that the soil is exerting on the structure, and the Y is the bearing length. So for Q, we have an equation that is Q is equal to 0.51 FC prime B multiplied by root over A2 over A1. Here B is this dimension, which is this perpendicular to the moment direction. So you know the value of D. So that is 0.51 if C prime is given, that is 6K thing for ground. And here you don't have the value of A2 over I1. You don't know this. If you don't know this, the uh, conservative uh, way is to consider that this ratio is 1, because it cannot be more than a 1. But what do you mean by that? Here, A1 is the bearing area for this steel plate, and A2 is the bearing area right over here. So you can see that the bearing area right over here will be at surface will be more than this than the bearing area in this plate. So it cannot be more than 1. It will be sorry sorry it sorry it can be it cannot be less than 1, but it can be more than 1. The conservative one is to consider that as 1, because uh, so we can consider that as 1. We'll check the later. So for that, you'll get a value of 1, and ultimately you're getting a bearing. Sorry, you'll multiply it with 20, which is B, and you'll multiply it with 1. So ultimately you're getting a value of 61.2. Keep inch. I will clear this part later on. Okay. The next thing is that you will have to find out the bearing length. For that, you have an equation that is F plus n over 2 plus minus root over F plus n over 2 whole square minus twice Pu F plus E over Q. We already know the value of Q, and we have to find out the value of F. Here, F is simply, we'll find out the value of F. F is simply the half of this. F is simply the distance from the middle to the mid of anchor rod. So that would be, F would be just 16 divided by 2, that is 8. And we have a eccentricity that we found earlier, that is 11.48 inch. And other, do you need any other parameters? And your n value is 26. Sorry, 22. So from there, if you put all the values right over here, and you have a load of PU value of 130. So if you put all the values in these equations, you will get a value like this: 19 plus minus 16.73. If you consider plus 1, you will get a bearing length that would be more than 22. But your bearing length cannot be greater than this n value, that is 22. So you'll not consider the positive one. So you'll consider the negative one. So you'll get a value of 2.27 inch. So now you can find out the value of tension. So how did you do the value of tension? So you have a Q value of 61.2, and you have a Y value of 2.27, and you have a vertical load of 130. So from there, you will get a value of, let me calculate. You will get a value of 8.92 K. So you know the tension and you know the shear value, total shear. So the shear is, I can write it right over here. Shear is, that is given 30 K. So you know the total tension, which is 8.92, and you know the total shear. So for the tension and shear, we will design the diameter of anchor rod, and we will find out the plate thickness. So we are halfway done. Let's assume that we are using 3 by 4-inch dia anchor rod. For that, what would be the shear capacity? You need a shear of 30 cubes for how many anchor rods? 4 anchor rods. So each anchor rod will get a shear of, we can call that each anchor rod will get a shear of VU would be 30 divided by 4. So that would be 7.5 cubes. So each anchor rod will withstand a shear of 7.5 kg. So now we'll check the shear capacity of the anchor rod for 3 by 4-inch diameter anchor rods. For that, we have an equation to check shear capacity. The equation is phi FB AB. Here, phi is 0.75 for shear capacity, and your HB for HTM A307 is fixed, that is 24 KSI, and your AV is for the diameter of 3 by 4 inch, your AV is pi by 4 multiplied by 3 by 4 squared. From here, you'll get a value of 7.96 kip. So which is the shear capacity is greater than the shear that a particular anchor rod is withstanding. So the anchor rod diameter is okay for shear. So now we'll check the tensile capacity of the anchor rods. Before that, we have to find out how much tension a particular anchor rod is resisting. So we have two anchor rods at tension size. Each each anchor rod is having a tensile force of half of the total tensile force, that is 8.92 kN. So that would be 4.46 kN. Now we'll check tension capacity. For that, we'll check tension capacity. For that, we'll have to find out the nominal tensile strength of A307 steel. We call that FT. And for A307, A307 steel, we have an equation to find out the nominal tensile strength of your anchor rod. That is 59 minus 1.9 FB. FB is simply, we can call that FB is VUV over AB. So we have an equation to find out the nominal tensile strength, that is 59 minus 1.9 VUB over AB, and that should be less than or equals to 45. So we'll find this 59 minus 1.9. We have a total, sorry, we have a shear of 7.5, if I'm not wrong, 7.5 in each bolt, and the area of the anchor rod is pi by 4 into 3 by 4 squared, and you will get a value of 26.7 KSI, and which is less than 45. Now we will find out tensile capacity. The tensile capacity, for that we have a formula of phi, the FT, what we have just found, multiplied by the area, cross-sectional area. Here phi is 0.75 and FT is 26.7 and AB is uh, this pi by 4 3 by 4 whole square. For that you'll get a AB value of 0.448 and you'll get a tensile capacity of 8.85 kip, and which is greater than the tensile force that is coming on the anchor rod, which is 4.46. So the anchor rod is okay for resisting shear and tension both. So now we'll find out the thickness of plate. For that, we have an equation. We have actually two equations. That is, Tp is equals to 2.11 root over Tu, the tension, and x over Pfy. It is for all cases. I'll show it a bit upward. Yeah, this is the equation. So, and this is the case, moment with uplift, the case we are solving. You have an internal equation for all cases. So you have an equation this. And if your y value, which is bearing length, is greater than m, then you have an equation this. And if your y value is less than m, then you have an equation this. Between these two values, the biggest one will be the controlling thickness. So we'll select that one. So for that, you have already found out the value of y, you have to find out the value of m, and you have to find out the value of x to solve this equation. So once again, I will say what is m and what is x. So your m is this, which is the from the middle of your flange to the edge of concrete, and you have an equations to find out the m, which is m is equal to n minus 0.95 d multiplied divided by 2, and to find out the x value, which is the from the middle, if I'm not wrong, from the middle of your flange to the middle of your anchor rod. So for that you have an equation which is this f minus d by 2 plus df by 2. So we'll find these two values. So for m value, we have an equation that is n minus 0.95 d over 2. Here n is in this case 22.95, and you have a depth of a section that is given, which is the column section that is given is W1265. So the depth is 12, but actually the depth is 12.122, but you can use 12" as well if not given, and you just divide it with 2. So you'll get a value of 5.2 inch. And you have a y value, what you calculated earlier, that is 2.27 inch. The other value that you need is x value. So for x value, you have an equation that is f minus d by 2 plus tf by 2. So your f in this math is half of this value, 16 divided by 2. 16 divided by 2, and d is, sorry, that would be minus, and your d is 12.12, and your thickness of flange, it should be given, and for the section what is given 12 and 22, and for 12 and 22 you have a thickness of 0.605 over 2. So from here you'll get a value of 2.24 inch. So you can see that your y value is less than m. If your y value is less than m, you have another equation for calculating TP, that is 2.11 root over PU multiplied by m y by 2 divided by p m y. So now you know all the values. In this case, that is 2.11, and you have a tensile strength on a particular total tensile stress is this should be the total tensile strength, not the tensile stress on a particular anchor rod. So it should be 8.92, and you have a x value of 2.24, and you have a v value is 20. You'll get it from the cross section or plan view, and you have a fu value is 36 because you are using a36 is still, if I'm not wrong. Yeah, you can see that you're using a36 is still for flat plate, and this one is your b value, which is 20. So your b value is 20 and your fy value is 36. So from here you get a TP value of 0.35 inch, and you get another TP value from here, which is PU in this case is 130 kg particle force, and your M value is 5.24, and your Y value is 2.27 over 2, and you have a P value of 20, and Fy value is 36. So you'll get another TP, which is 1.82 inch. So your plate thickness is this, which controls. So your plate thickness is this, and your bolt will be 3/4 diameter anchor rod. So the anchor rod would be 3/4 inch dia, and your plate thickness would be 1.82 inch, or you can use 1.85 inch.